For this first example, we're going to look at how to graph a line when it's in point-slope form. So this is point-slope form, y minus y1 equals m times x minus x1. So m stands for the slope, and then x1, y1 stand for a point on the line. So in order to graph this, we need the slope and we need a starting point, and the starting point would be x1, y1. So this example in blue, y minus 2 equals 2/3 times x plus 1. That is in point slope form. So we need to find the slope. So the slope is what's in front of the parentheses. So here's our slope. So our slope is 2/3. And when I graph this, if the slope is positive, I'm going up. So I would label my numerator up. And you're always going to the right to begin with. So the denominator will be labeled as right. The only thing that would change in this scenario is if it was negative. Instead of up, you would write down and to the right if it was negative. So we have our slope. It's 2/3. And then we need an ordered pair to begin. So our starting point, our ordered pair to begin, is x1, y1. So if you look at point slope form, x1 is right here, and y1 is right here. So I'm going to circle those in this point slope form. So this is my x1 and my y1. However, if you look at the formula for x1, the formula has a minus sign. So in order to get a plus sign, a +1, there had to have been a double negative. So that means my x1 is -1. And then my y1, well, the formula has a minus sign, so that accounts for this negative. So my y1 is just +2. So an easier way to think of this is when you circle your values for x1 and y1. So when I circle this, I flip the sign to a -1. When I circle this, I flip the sign to a +2. So now I'm ready to graph. I'm going to start with my ordered pair, -1, 2. So right at the origin here, I'm going 1 to the left and then up 2. So there's my beginning point. And then from there, I'm reading the slope. I'm going up 2 to the right 3. So up 2 to the right 3 would be right here. Up 2 to the right 3. Once I run out of room, I'm going to go back to my beginning point right here. And instead of up and to the right, I'm going to switch these to the opposite, which would be down and to the left. So I would go down 2 to the left 3. And then here's my line. So for the second part, we're deciding whether this table is linear. So in order for a table to be linear, it has to have a constant rate of change. Meaning the slope has to be consistent through the entire table. So how do you find the slope or the rate of change? There is a formula, y2 minus y1 over x2 minus x1. Or someone might say the change in the y's over the change in the x. So in fact, I'm going to kind of use this option in order to figure out whether this table is linear. So the change in the y's. So we're going to look at this first pair here, -2, -4, and then -1, -1. And we're going to find the change in the y's. So what that means is I'm asking myself, how do I go from -4 to -1? In order to go from -4 to -1, I add 3 to that. And if you're having trouble figuring out that +3, you just take the bottom number, which was -1, and you subtract the top number, which was -4. And if you add the opposite, -1 plus 4 is 3. All right, so that's the change in the y's. Now I need to find the change in the x's. How do I go from -2 to -1? I would add 1. So this gives me my slope. My slope is equal to 3/1. So that means it has to be 3/1 for every pair here. So let's check the next pair. From -1 to 2, I add 3. And then from -1 to 0, I add 1. So far we've stayed consistent. The slope is 3/1. Our final pair here, from 2 to 5, I add 3, and from 0 to 1, I add 1. So this is linear, yes, and the reason is the slope is 3 over 1 throughout the entire table.